Welcome back. Well, today we're going to talk about the rules of differentiation and how to find derivatives rather easily. Many of you probably have been using this form to find different derivatives. The limit, all right, as possibly h approaches 0 of f of x plus h minus f of x all over h, and that is how you've been finding your derivatives up to this point. And at this point, you're probably getting very frustrated because this is a very long and tedious process. Well, I'm here to help tell you that you can do this no longer, as we are going to go through 3 basic rules that can be added and subtracted together, and it'll make your life a lot easier and help you solve problems much quicker. The first is what's known as the derivative of a constant rule. The derivative of any constant, because it is a horizontal line, and since derivatives are slopes of a curve, we know that the derivative of any constant will equal 0. So that's the first rule. The next rule is the power rule. I've got the power rule. We have f of x, which equals x to the negative n. Whenever you have a power function, where you see many, all right, all polynomials are power functions. Square root functions, and whatnot are power functions as well, and we'll talk about those in a little bit. But the power rule states that when you have this function like this, you can take the exponent, put it as a coefficient, and then subtract 1, and that gives you your derivative. We can add a constant multiplier rule to this, in which we have a times x to the n times the derivative of f prime of x would equal a coefficient times x to the n times x to the n minus 1, and that is the power rule. To give you some examples of how we can do this, we'll go through examples right here. We're going to add and subtract these, so we're going to use what's known as also the sum and difference rule. So if I want to find y prime, okay, of this function right here, we would find y prime or dy dx, the derivative. So instead of using the limit definition, we can find this by using the power rule. We find each of these terms separately. Okay, so we're going to find the first derivative of this first function. So the derivative, according to the power rule, would state that we're going to take 3 times x. We take our 3 and then subtract 2, or subtract 1, that is, and we get 2. And that would be its derivative. It is just that easy. The next one, if you want to take the derivative of 2x, well, the derivative of 2x using the power rule would simply be 2, all right, times the power of this one, which is 1. So we have 1 times x to the 1 minus 1, which we know is the 0 power. Well, x to the 0 power is 1, so we just have basically 2. So what we have here is 3x squared plus 2. And then we have the derivative of 4, which we know is a constant, which will be 0. And therefore, my friends, this is your differential equation. That is the slope equation, the derivative, using the power rule. A lot easier, right? Yeah, a lot. Saves a lot of paper. Well, we also have probably this. Well, you might look at these and say, well, that doesn't look like a power function. Well, if we change this around, I'm going to get color for us. We can take y, and we can write this as 3 times x to the negative 4th power, using a little algebra. That's algebra in Spanish. And then we're going to take 4 times x to the negative 1st, and then we'll just keep minus 6 right there. Well, we took this two rational functions and made them into power functions. Because once we do that, we can use this simple rule, the power rule, and take 3 as our multiplier. We take negative 4, put it in front, so we take 3 times negative 4, which will give us negative 12. We would then take x, subtract 1 to negative 4, which gives us negative 5. We would then take this and say, okay, plus 4 times negative 1, use the power rule, or constant multiplier rule, we get negative 4. X, subtract 1, we get negative 2. And then finally, we take the derivative of 6, which is 0, and we would just leave it there. We can then simplify this, negative 12 over x to the 5th. And then we have negative 4 over x squared. Back to our rational functions, and back to our answer, which is our derivative. Once again, fast, efficient, saves a lot of space, and we got that done. Well, we're not done yet, my friends. No. If we want to figure out some more, all right, we can find these, because these too are power functions. We say the cube root. Well, taking this, y equals, take the cube root, we can have this as x to the 1/3 power. Using the power rule, we can say y prime equals, take the 1/3, x to the, subtract 1 to 1/3, and we have negative 2/3 power. Oops, that's a 3, by the way. Which can be simplified to 1/3 times x to the 2/3. And then we have this one, and that would be our answer. And then we can take now the derivative of this one. Once again, put the power, put it in front. 2/3 x to the negative 1/3 power. Now, just so everybody's familiar with this, which can be simplified, yes, to 2, and then 3 times x to the 1/3, and that would be our solution. Now, just so you know what this is, just for recalling, whenever you have a power in the top, okay, in the numerator, that is the power of the function. Okay, this is the root of the function. All right, that is what it's in the denominator when you have a power. So, in all of this, we just did 4 problems on one little slide using the power rule. The power rule is a very efficient way of finding derivatives, y prime, or we can call it dy dx. In any case, that is how we can use the power rule. I'll have additional tutorials and slides on how to do some different power rule equation, or how to solve different power rule problems in different applications. I hope this helps you out, saves you a lot of time, and I hope you can do very well on the rest of your calculus homework. All right. Good luck and God bless.